Solving absolute value inequalities. This would be in the McGrawHill book 5.4. Let's talk about this one, guys. All right, so to start us off, let's go ahead and talk about something that is new, okay? Something that is new to this idea of solving absolute value inequalities. Now, to bring back a little bit of what is absolute value, remember that absolute value is distance. Distance, okay? How far that number is from the number 0. It can never be a negative number because distance can never be negative. So if you were to ask yourself, how far is the number 742 from 0? It's 742 units away from 0 to the right. The number negative 57 is 57 units away from 0 to the left, okay? Now, absolute value inequalities are just going to be pretty much inequalities, right? Inside of absolute values, okay? Now, obviously, it's going to have a little bit more than that. That what I just put right there was kind of weird and not really a solvable thing. But you'll get the gist as soon as we start getting example problems here. I was just putting an inequality and absolute values around it. Now, something else that I want to bring into your brain is the idea of when we're solving absolute value, two things have to come to our mind: the negative number and the positive number. For example, what number is 7 units away from 0? What number has the absolute value of 7? And that is two different numbers. X can be the number 7 because 7 is 7 away units from 0. And X can also be the number negative 7. It's 7 units to the left of 0. So we have two different cases. We have to consider the positive and the negative inside of our absolute value so we can generate the answer that's right there. All right. Okay. Now let's go ahead and talk about this little study tip. Very important. Very, very, very important. Now, in absolute value inequalities, whenever we are using, here we go, the greater than or greater than or equal to. So whenever we are reading this right here in the primary, in the original problem, that means that we are talking about or inequalities. Greater than or equal to. If it's one of those, it's going to be an or inequality. If it's an a less than or equal to, that is what's going to be an and inequality. All right. Also, the graphing is going to help us understand it a little bit better. Okay. So if you get stuck, if you don't remember these little tips, the graphing will also paint a better picture. All right. All right. Let's go ahead and try example number 1 to see what it is that we're talking about here. All right. So example number 1 is solving an absolute value inequality. And you can see that it's less than. Do you guys remember what it is when it's less than? When it's less than, we are using and. Okay. So we are using and. So if you need to make yourself a little side note, before you get started, by all means, create yourself a little side note. All right, so let's go ahead and get started. How do we solve an inequality that looks like this inside of absolute value? We need to create the two cases that we're talking about. Case number 1, we need to talk about where this quantity right here inside of the absolute value is positive. So we need to solve it in its positive version. Then we also want to solve the same exact thing, but when the inside quantity is negative, okay? Because remember, the positive and the negative number, as long as they're the same number, will be the same distance from 0, okay? So we go ahead and solve this as we would any other. Take 5 to the other side by the inverse operation of addition, which in this case would be subtraction, and that will leave you with m is less than negative 2. Remember, we do not flip our original sign right here because we did not divide or multiply by a negative number. So we get to keep this as one of our steps here for our solution. Next, on this side over here, we must distribute this negative sign. What that does is simply it changes everybody's symbol inside. Whoever was a positive becomes negative. Whoever was a negative becomes positive. So now we have negative m minus 5. Keep the symbol, keep your 3. Nothing has happened there. From here, we're going to go ahead and take 5 to the other side. Same idea as we did before by the opposite operation, which in this case would be addition. And now we're left with negative m less than 8. Here we go. Cool. What do you think we do here? Well, right here, we need to get m by itself completely. That means this -1 that's right here, which is -1 times m, we could take it to the other side by the opposite, by the inverse operation. We know that -1 right here, it's originally multiplying. So by dividing by -1, we can get rid of it or take it to the other side. -1 divided by -1 is simply 1, and 1m is just m. Remember that we divided by a negative value, so we have to flip our sign. Do not forget. So now m is greater than -8. Cool. Now, we have these two things right here. All right. We need to graph those two ideas, and we can also, since, it's something that we've learned in the previous lessons, is how to write our inequality, the several different ways that we can write our inequalities. What I'm going to do right now to see if it can help us understand that this is an and problem is I'm going to graph it to see what it looks like. Very quick little sketch. So we have a number line right here, or values, where you have the number -8 somewhere all the way on the left-hand side right here. And then you have 7, 6, 5, 4, 3, 2. That would be -2 right here. And then let me just add some tick marks because I feel like it. All right. Now, my red one, which was m, are my numbers that are less than -2, looks like this. Open circle, because of the inequality symbol that I have right here. It does not have the or equal to. If it had the or equal to, we have a closed circle like that, but it's not. So we're going to leave it open. So all the numbers I said, m are all the numbers that are less than, m are all the numbers that are less than the number -2. And every time we say less, we're going to the left. Cool? Cool. All right. And then here we have m are all the values greater than -8. So starting at 8, open circle, once again, we don't have the or equal to symbol. Values that are greater. So here we have a shared region. Okay, we have a shared region right here, which helps us understand a little bit more of the shading or the shared region of our solutions here, the solution sets that we have. In the previous lessons, we've learned that whenever they have most of the time when they clash like that, when they combine like that, it's an and the other times that we looked at, the ones that go like this, opposite ways, would be an or problem. All right. Now, it doesn't always work like that, just to let you guys know. It doesn't always work like that, but this could kind of help you paint a little bit a better picture. Now, here's the graph of it. What I want to do right now is I want to properly write our solution for this. So there are 3 ways of writing this. Number 1 is pretty much what we have right here, which is m are my values that are less than 2 or -2, I'm sorry, with the word n inside, compound word right here. And m are my values that are also greater than -8. So this is one way of writing our inequality with the word n in the middle. We can also write the inequality with the without the word, where we can write it like this. I have my smaller number, which is -8. It's located on the left side. And then my larger number right now, which is -2. And my solution is set to fall inside, meaning it's greater than -8, but less than -2. That's another way of writing it. The last way of writing it, don't forget, is we could do set notation. Set notation is going to be our little grouping symbol that looks like this. And then we go ahead and mention, in terms of my m values, the solutions are greater than -m, -m, greater than -8, but less than -2. Close set notation. Ba-dee-ba-da-ba-doo. And here's going to be our final way that we can write our solutions. Once again, that's called set notation. Boom. All right, there we have it. We have 3 ways of writing our solution, and we actually have the graphed component. Now, a lot of the time students like to go like this, so they don't visualize anything that's outside of their actual solution set. Just remember, the solution set is the green area in this case. Cool. Moving on. All right. This is where I want to stop this. I want you to try this one on your own and then just press play to check your answer. Let's go. All right, guys, here we go. We are dealing once again with a less than. A less than is going to prompt us with and. Okay? Less than is going to prompt us with an and inequality. So we first have to deal with the original quantity here of 6m plus 12. Keep our symbol here, less than 12. And then we're going to have our second case, which is the negation of that, the negative aspect, which will still have the same distance away from 0. Okay, so here I will do it in red. We'll start by taking 12 to the other side by opposite inverse operation. 6m less than, we now get 0 on this side. A lot of students freak out because they get 0. It's okay, 0 is still a number. Keep working as if that was any other number other than 0 if it freaks you out. And now 6 divided by 6 is 1, so 1m is just m. Symbol stays the same way. 0 divided by any number in the world will always be 0. Here's one of our solution pieces. And the next one is, and I don't know if you noticed, but I'm not going to box it in because I don't want to say that this is my answer. It's not my final solution. That's a piece of it. That's half of the problem. And I was doing the other problem and I boxed it in. I was getting cringy. I was like, ugh. My heart was telling me, stop it. Don't box it in. Because then it looks like it's like it's a final answer. Or students are going to mistake it for, oh, I can write it like that and just leave it like that. Nope. All right, we're taking 12 to the other side. Right here is addition. Pew, pew. In this case, our 12s on the right side are not going to cancel. They are going to make 24. Here, we're going to go ahead and we are understanding that -6 is multiplying by m. So the opposite operation will be division by -6. Whatever you do to one side, do it to the other side. That's your, what is it? Properties of inequalities. So we have m. We must flip. I'm trying to think of the term. Properties of equality, properties of inequality, properties of inequality. It'll come to me. All right, so flipping my symbol, bitty beam, bitty bum. That is going to give me right here -4. Underline this sucker. All right, so once again, we have an and problem. I'm going to go ahead and write it out. I'm going to write my solution out before I graph it this time. So it's kind of like in order. All right, now, here's what I'm going to do for this one. What I'm going to do for this one is I'm going to kind of tell myself in my head what's going on here and here, and just paint myself a picture so my answers can flow a little bit nicer. Okay, on the left side, I have my solution set are all the numbers that are less than 0. So I'm picturing that in my mind right now. My solution numbers, my solution set are all the numbers that are less than 0. Okay, gotcha. 0 to the left. Gotcha. On this one over here, I have my solution numbers, or my solution set is any number that's more than -4. Okay, so -4 is located to the left of 0. Okay, gotcha. It's every number that's greater than. Okay, so I could see what's happening. So we have 0, we're going to the left, and then we have -4, we're going to the right. Okay, and it's going to be anything in between. Now, a way that we can write this, okay, a way that we can write this is obviously what we said before. We can go ahead and write them separately, which is all the numbers that are less than 0. Go ahead and put your compound word right here, and all the values that are greater than -4. Cool, that one's done. Now, to write it this way without the word or, I'm sorry, and, to write it without the word and, a lot of students freak out and they don't really know how to grab this. Look at the number that's right here. That's my lesser value. That's all the way to the left. And the number here is all the way to the right. So put it in that order, -4, and then put 0. Inside, you're going to put the variable that you're working with. Right now, we're working with the variable m. And now, all you have to do, this is kind of like a little cheat code. You will always have your symbols face this way. Okay, always, because you want your m numbers to be more than -4, but you want them to be less than 0. Cool. If that's something that helps you, great, use it. If not, if you have a better way, cool. Just remember that there is another way that we can write this, where 0 would go that way, -4 can go that way, but remember that your symbols must flip as well. Okay. I don't recommend you guys playing around with moving things around because then you're going to mess up your brain All right, now the last thing I'm going to do right here is really quickly put it in set notation in terms of M, values that are greater than -4, but less than 0, close set notation. Boom. 3 ways of writing our solution. I don't know why there's so many ways of writing a solution set. I just teach what I was told, and this is not cool, right? It's a waste of time. All right, here we go. Let's go ahead and choose number -4 right here. 3, 2, 1, 0, and then some tick marks just because my OCD needs it. Boom. And then we have the red one was 0 less than 0, open circle because of the inequality symbol that I have. And we're going to the left. Over here, we have numbers that are, more than -4, open circle, to the right. And this would be our shared region, obviously. Let me just put that. Once again, my OCD calls for it. All right. Now, the rules remain the same. Just to give you a little reminder of what the solution sets are here, or what the solution is here. Any number that is outside of that green shaded region, it is not part of the solution. It will not make this true. And remember that the beauty of algebra is that 99% of the times you can check your work by plugging it back into the original equation. So if you choose any number that's to the right of 0, or actually 0, or any number afterwards, you're going to notice that your original inequality, located up here, blip, 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 will not work, will not be true, will give you a false statement. Now, the reason why I said including 0, because 0 is an open circle. So open circle tells you what we do not include that number. It's not part of my green shaded region, even though that little green piece right here seems like it is. Now, everything in between -4 and 0 will be a true statement once you plug those numbers in and you check your work. Once again, -4 will not make your solution set true, or your inequality true. All right, here we go. Example number 2. I'm going to go ahead and read the green text because every time there's a new example, it has a new thing attached to it. So let's see if there's anything here. Absolute value inequalities, less than, with no solution. Okay, so once again, we're sticking with less than, which means we are still using and. Okay, now you can see it right here. You can see it right here. Know that we are saying less than because our absolute value is located right here. So the way that we read it, it's like regular reading from left to right, right? Then graph the solution set. You're reading from left to right. That's the same way that we would read this inequality right here. You have your absolute value thing, which you could read it if you want. I'm not going to do it, is less than -5. So that is what prompts us to say less than. If this was flipped, if our absolute value was right here, then we would actually be working with a greater than. It's tricky, I know, but for right now, let's not get our brains mixed up. We're working with an and because it's a less than. Whew. Okay, now, why does it say no solution? Think about it. I want you to use your brain power right now and think, why does this have no solution? Think about it. Okay, enough time. In the previous lessons, we've learned that absolute value cannot be negative. So we always said, if you have something that looks like this, meaning what is the value, what's the value that X should be, for it to be -12? And that's impossible because absolute value cannot be negative. If you put here a -12, the absolute value of -12 is actually +12. So there's no way, absolutely no way you can get a negative absolute value. You will always generate a positive value because it's distance, okay? So if you see what's going on right here, I don't want you to just say, oh, there's, you can get a negative number. Well, the thing is, can you think of any number that when you plug into this question mark will be less than the number -5? If you think about right now where the -5 is located, okay? Can you think of any number that will be located anywhere that way? Anywhere? And the answer is no, because whatever number you put into this question mark, any number you put into this question mark will give you a positive number. So let's say that 0 is here. Any number that you put in that question mark will give you a number, an answer that is located in the blue region. So for that reason, we have no solution in this, for this inequality type. because the absolute value of n minus 1 is an absolute value expression, it cannot be negative. So it is not possible for that to be less than -5. Therefore, there is no solution. And the solution set is the empty set. It's an empty set. There are no numbers in your solution plate. Got it? Got it. All right, talk about it. I want you to talk to me right now through the mic, through the computer screen. Just kidding. That'd be weird. Is the solution set of this inequality right now also an empty set? Explain your reasoning. So you're probably thinking two things. You're probably the person that jumps right into conclusions and goes, yes, it's an empty set. There's no solution because we have a -5. That's the person that you could be if you just said, yeah, there's no solution. And then the other person is like, oh, every time they ask a question right after, when they're like, oh, what about this time? A question like that, then the answer is always the opposite. So whatever the case may be, one of you is right. Well, here's how we have to answer this one. Remember that before we can ever get started with what's inside of our absolute value, we want to get this right here by itself on one side of the inequality. So this -6 must be taken to that side so we can start working. All right. What we do here is we would take 6 to the other side by doing the opposite, which is adding. What do you think happens now? What happens now? What happens is that this absolute value of n minus 1, keep the same symbol, this, we now get a 1. And look what happens. There is no longer a negative value on the right side. So the answer is, no, it's not an empty set. We do have possible solutions. Actually, not possible solutions. We do have solutions that will make this inequality true. Now, we're not going to solve it. It didn't ask us to. But if you want to, you can go ahead and do that. All right. All right, moving on. Word problems, yay. All right, this is going to be quick and painless. I promise. I'll try to make it painless. Now, I did try to read this question and try to make it sense in my head. Make it make sense in my head. And I'll try to make it make sense in your head as far as like the story, okay? The numbers are easy to work with. It's just the story that sucks. All right, follow me. So we got Jonas is a software developer who wants to determine whether the changes he made to his program are popular with users. He releases a survey to get some feedback and finds that 72% of the users like the change, and then the rest of them are like, no, they suck. The margin of error, this word right here, means how far you can get off of the regular number. So for example, think about your temperature, like your human body temperature. There is a margin where this is you. Hello. And there are numbers where your temperature is stable, meaning your body is fine. Now, if your temperature drops too low, then your body's tripping out. If your temperature rises too high, so I'm going to put a minus sign here and a plus sign here, then your body's once again tripping out. Okay, that's when you're going to have a fever. So that's what I want you to think about right now. The margin of error is within 1.8%, which means imagine if let's not talk about temperature anymore, and now let's talk about 72% is the number that we're focusing on right now, and the margin of error, meaning the the safe zone is 1.8 that way, and I'll put it in red so it should signify that we're going down. 1.8 that way. That is the safe zone. If you are outside of this little safe zone, then that means warning. So in regarding the temperature one, if you are outside of this safe zone, like too low that way, then you're sick. And if you're too high that way, then you're also sick. This would be your safe zone. Hello, happy. Wait. Let's put a little smiley in green right here. Your body is still doing okay. That's normal, okay? So apply that to the numbers as well, okay? That means Where am I? Okay. The margin of error is within 1.8%, which means that with a reasonable level of certainty, the actual percentage can be said to fall within 1.8 of 72%. That means that it can either fall 1.8 more than 72 or 1.8 less than 72. Now, the people that are probably already doing some math in their head or like trying to get ahead, maybe you did this and good job. That is exactly what you need to think about. If we are at 72 and we go 1.8 to the right, we will be at 73.8. Okay. If we are at 72, but we go 1.8 to the left, we would be at 70.2. Okay. So once again, for you, let's bring it back to the temperature for those of you that are not understanding it. If you go below, and this is fake, obviously, this is not your real body temperature. 70s are way too low. You're supposed to be in the 90s. If you go below 70.2, you will get sick. At 70.2, you are still in the safe zone, still safe up to that number. Don't go below it. If you go up to 73.8, you are still safe, but that's the threshold. Don't go past that. All right. This is what that means. Okay. Whoo. What we're going to do right now is we're going to set up an inequality using absolute value to represent our little story of our smiley faces here. Okay. Now, bear with me, and I hope that it is not as confusing as it probably seems right now. Here it is. Whatever actual number Jonas finds, right? We are going to want to find the difference between that number and 72. We want to find how far is that actual number. We're trying to compare actual stuff with his, this is kind of like his hypothesis, right? And what is difference in math? When you say difference, what do you do with numbers? Difference is distance. Distance is subtraction. When you want to find the distance between two numbers in a number line, you subtract them. So whatever actual number, percent he finds that people really liked or disliked his software, then we're going to find the difference. We're going to take it away from 72, because then that will tell us if that number is 1.8 or more than 1.8, right? It's like some other number that's not 1.8. Remember that our safe zone is you can either go above 1.8, up to 1.8 or as low as 1.8 downwards. So we don't want to go more than that number right there. We want to be less than that number, or we want to stay at that number. Those are my thresholds. Don't want to pass 1.8. Now, how in the world does this become an absolute value inequality, Mr. C? Why does this become an absolute value inequality? I don't get it. Why do you have to put absolute values here? What if Jonas actually conducts a survey and the actual number that he receives back is the number 71? What do you think happens when you put the number 71 in there? You will get this. 71 minus 72. How much is that? Wouldn't that give you -1? That's weird, because you want to have a positive number, because it would make sense in the real world to have a positive number of change, right? Of what actually, the distance between those two numbers. All right. This right here, having a -1 pretty much means that it went down from the estimated amount, right? But we want to just deal with positive numbers, as this is considered in distance of numbers to compare the numbers. All right. I know. If you're thinking, wow, what a negative number is still making this true, you are right. All right. A negative number will still make this true, because it does show that it went down from his findings. With that said, let's go ahead and complete this. That's the part that I'm like iffy about this problem, where negative numbers are not too weird to get. Because even though we get a negative number, it still makes it true. Look, a negative number is less than or equal to 1.8, isn't it? Yeah. All right. So let's go ahead and do this. This is where we go ahead and separate our two cases. the positive idea of this would be x minus 72. And you're going to see where, where when we finish the math here, you're going to be like, did we really have to do all this? We actually had the answer all along. Shh, trust the process. Trust the extra work. And then this one is where we go ahead and find the negative idea case. Here we go. All right, so on my right side, I'm just going to go ahead and take 72 to the other side by addition. Cancel, cancel, leaving me with x less than or equal to. Here's where I get 73.8. Yeah, have you seen this before? Have you seen that before? Wow, we actually did all this just to get the same numbers. Yes, I know. But the idea is to represent it. All right, the idea is to grab what our brain kind of takes as a little bit common sense or funny little baby drawings and turn it into algebraic inequality inequalities. You know. All right, in this one, well, let's go ahead and distribute that negative. That negative is going to just negate the value of all the values inside here. Negate the values of all the values. Yeah, cool. You're doing really well, Mr. C. Yeah, 1.8. Bada bing, bada boom. All right, on this case, we're going to take 72 by subtraction. And this last step is what's going to get our negative. This is where our absolute value actually plays a role. All right, this is where absolute value plays a role. Here's where we will get negative 70.2. And the whole entire reason, we simply got absolute value bars around our inequality was literally for this one step right here. We take this -1 to the other side. We are literally grabbing our negative values and saying, hey, no, we want a range of positive numbers. Oh no, I went back way too much. All right, whatever. Our negatives here will cancel out, leaving us with a final idea of x. Remember to flip your symbol because we did divide by a negative here. Wow. Flip your symbol, giving you 70.2. Now, look what that says. Hopefully you guys still remember the little picture that we had up there. That little picture, come on, computer. All right, here we go. The little picture said the values that we want have to be less than or equal to 73.8, and they have to be more than or equal to 70.2. All right, it gives us a nice, beautiful little pre-sentence right there. Now, I won't put you to torture and have this right two other different ways. Cool. So we'll keep it there. All right, example numero 4. Solve absolute value inequalities. Now, look at what we have. We have greater than. Greater than means we're going to get driven by or. So I challenge you to stop this right now and try it on your own. Wow, my Siri is just tripping out. All right, so nothing here changes. Nothing at all changes. So the same idea is going to happen. We're working with an absolute value. So that means that we are going to be working with our original idea of 2m minus 9 is greater than 13. But then also we are going to use the negative, the opposite of this quantity right here. Symbol stays the same, 13 on the other side. And we take 9 to the other side by adding. They cancel out, leaving us with 2m is greater than, what do we get here? 22. Take 2 to the other side by division, which is the inverse operation of that multiplication that's happening. 2 divided by 2 is 1, and 1m is just m. Keep the symbol the same. You did not divide by a negative number. Next, we go ahead and distribute our negative here, changing our values to negative 2m plus 9, greater than 13. Right here, we take 9 to the other side. Whoops, in blue. By adding. And that is going to, no, not by, no. I said subtracting here, but then I wrote adding. I wrote subtracting, I said adding, and then I wrote adding again. So that will give me here 13, 4. As our final step, we will divide by this negative number, having us flip the sign. If you don't flip the sign, your inequality will be wrong, and you will be using wrong numbers for your solution set. So flip sign right here, flip. And flip my sign. 4 divided by -2 is -2. Wham. Cool. Now we have these two ideas. Let's see what it looks like. I'll go ahead and write the answer right next to it or right under it, but I just want to see what it looks like right here. Think about the number -2 right here. And then you got 3, 4, 5, 6, 7, 8, 9, 10, 11. Here's 11. Now at 11, which I did in red, we have an open circle, and we were talking about the values that are more than 11. So that's going to be shading to the right. Here in red, we're talking about the values that are less than -2. So open circle at -2, and we're going to the left because those are the ones that are less than. All right, here we go. Let's go ahead and bring these together and write a beautiful solution. The first idea is, well, I pretty much just did it right now. I mean, which you could do it like that, which is putting the word or in between them. Or you can write it in set notation. You know what? I don't feel like doing set notation right now. You guys should already understand how to do set notation. It's the same idea, but just with the grouping symbols around it. All right. Nothing new, nothing crazy. All right. Check problem. Try it out. Don't cheat yourself. All right. So for this one, I'm going to go ahead and give you the answer. I don't want to walk you through it because I want to see if you are able to, maybe you made a mistake. Maybe it's not what you got. It's not the answer that you got. So what I want you to do is grab the answer that we have right now, go back and check your work. If you made a mistake, change it. If you didn't, kudos to you. All right, we're at 2, 3, 4, 5, 6, 7, 8. Boom. Some little tick marks just for my sanity. Here we have closed circle on both of these quantities. So at 2, I want numbers that are less than 2. So we're going to the left. We are shading to the right. All right. Now here at 8, we also have or equals to. So we're using a closed circle. And it says that all the values that are greater than 8. So we're shading to the, oh, did I say the right before? I meant 2 to the left, 8 to the right. Cool. Now, once again, if you made a mistake, do your error analysis. All right. Now, for this right here, it's a little study tip. Now, it's very simple. It's very common sense. We've already talked about this in the past, but think about something that's, if you're at 1, right, and you're at 1, and it says, or equal to, greater than or equal to 1 means you're going to the right, right? So take that idea right there. And now let's go to this blue one right here, which is going to be, I'll go ahead and put 11 right around here. Now, it's going to be less than or equal to 11, which is that way. Now, think about this for a second. Think about the solution set of this and this right here, right? The solution in red and the solution in blue. Can you think of a number? Can you think of a number that is not part of this? Now, can you think of a number that is not part of this? They overlap right here, making every single number in the world a solution. Okay, there are no open circles, and these two arrows are pointing opposite ways. That means every single digit on the number line is a solution. I believe this is the last one. All right, let's go ahead and finish it off. Good. So think about it. Why is the empty set of solutions blah, 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 but not the solution of blah, blah, blah? Think about it right now. Let it simmer in your brain. So this one might have broken your brain a little bit. All right. So what I'm trying to ask you right now is, how come this one right here that we spoke about before have no solution? How come that one right here, right over here, has no solution? No solution. But this one does have solutions. What do you notice? The only difference is this. I hope you caught that right away. The only difference is that. All right. I'm going to put here yes for solutions. Whoa. Yes for solutions. So can you think about why they have solutions? Or I'm sorry, the bottom one has solutions. The idea is very simple. The idea is exactly what I explained before. Whatever value comes out of this green area is going to be a positive number. I don't care what you say. Any value, or I'm sorry, positive value or 0. Any positive number or 0 will always be more than 5. It can never be less than, and when I said 5, I meant -5. It can never be less than -5. That is why that is impossible to happen. That cannot happen. There's no such thing that can make that true. All right. Now, when you go down here to the bottom, you could see that we have a little bit of flexibility where, look what happens. Whatever number we put right here in blue, we're going to generate either 0 or a positive number, which all of those will indeed be more than -5. Obviously never equal to, because we can never generate a negative number out of that, but positive 5. Now, once again, I will challenge you to complete this one without the guidance. I'm going to go ahead and provide you with the 2 answers that you should get at the end of it. Go back, check your work if you need to. Now, notice that we're working with a greater than. That means that we are going to have an or set of solutions here. The first step that we're going to have is where n is greater than or equal to 1, and the other one where n is less than or equal to 11. All right. You will also be responsible of graphing this without the guidance. You got this. Kill it. If you have any questions, ask me. Peace out.